So in this video, we are going to look at relative minimums and maximums, continuation of multivariable calculus. So with definition, a function of x, y has a relative minimum at a point AB if the function xy is greater than or equal to the function of AB for all points x and y in some regions around AB. These are all definitions you need to know, right? But the whole idea is that at the end of this video, you'll be able to find the critical point, then use the critical point to find whether the function is a relative minimum, relative maximum, saddle point, or its relative maximum, relative minimum, or saddle point. So these are some things that you need to know after the end of this video. Yes. So these are our definition, but the one which is most important is what I'm going to show you here. So then, suppose that AB is a critical point. So always finding the critical point is the main important thing. The moment you get a critical point wrong, it means that your answers are going to be wrong. So please pay attention. Please pay attention to how I'm going to teach you to find the critical point of a given function. Okay, so for us to find the D, which in this case you are using the critical point, and based on the values you get for D, you're going to conclude whether the function is relative minimum or relative maximum, or even the point that you had is a saddle point. So for example, let's take this. So D equals a function of a and B, which is equal to this. So the most important thing is this one, for you to find whether a function is relative minimum, relative maximum, a saddle point. This is the formula you need to know offhand. Let me explain the formula to you. This formula simplifies that first you need to find the function of xx. That means that you find a function when a function is given to you, the function of the partial derivative of the function with respect to x twice. The same thing multiplied by the function of the partial derivative of the function of with respect to y twice, and then minus the partial derivative of the function with respect to x, and then you do another partial derivative of the function with respect to y, and you input the critical points, then you square it. And in this case, the value that you get, if the d that you had is greater than 0, and then the fxx is also greater than 0, then there is what? A relative minimum. Let's note that. And if you find the d and the d is greater than 0, and the fxx is less than 0, then it is what? Relative maximum at a and b. But in this case, when you find d and d is less than 0, then it becomes what? A saddle point. And if d is equal to 0, then it can be relative minimum, maximum, or saddle point. These are the main important thing you should know when finding the relative minimums and maximums, right? So for you to get it, the whole idea is that finding the critical point. How do you find the critical point of a function? So then we are going to take one example. I'm going to break it down for you to understand ways. I'm going to teach you how you can do that to find the critical point in various using different functions. So let's take this question, right? Let's take this question. But let's note something here. Note that if d is greater than 0, then both the partial derivative of a function with respect to xx, ab, and yy will have the same sign. So the first two cases above could just easily replace f of xx and f of yy. It's simple as that, right? So that is it. So we can replace this with f of xs or f of yy. But we simplify with, for us to use what is here, we are just using f of xx, right? So for you to be using the classification of the critical points, let's use f of xx. So we have an example here. We are supposed to find the critical point of the function 4 plus x cubed plus y cubed minus xy. But the same one who asks, what is a critical point? When we say a critical point, what does it mean? So a point x naught y naught in the domain of a function fy is called a critical point of a function if the partial derivative of the function with respect to x after the substitution of the point given is equal to 0, and the partial derivative of the function with respect to y after the substitution of the point is equal to 0. Or if one or both partial derivative does not exist, then it's the critical point. Very simple as that. So let's go back to the slides and see what is here. So how do you find the critical point? Let's pay attention here. For us to find the critical point of this, first you need 5 things, right? First, you need to partially differentiate with respect to x. This is the first one. Partially differentiate with respect to y. Then you go to f of x, f of y, and f of what? xy. These are the 5 things whenever they ask you to find the critical point and also classify them. You need to do all these 5 things because it's going to help you. Because from the formula, we need f of x, f of y, f of what? xy. But one who asks, why do we need f of x and f of y? The f of x and f of y will help you find the what? The critical point. In this case, after getting the critical point, it will help you to classify the critical point, whether it is relative minimum, relative maximum, saddle point, or when d is equal to 0. So let's do something. How do you find the critical point? That is the main thing. We finding the critical point first. We use the f of x and the f of y. So first, you're going to equate this to 0. That means that the f of x here, this side will change to 0, and here, this side will change to 0. Then in this case, find the value of x and y. In the case that when they give it to you and x is not squared and y is not squared, then you can use simultaneous equation to find them. That's what, let me explain it what I'm saying. So you can use the simultaneous equation on any simultaneous equation. Let me see one question here. In this case, as you can see here, they had when you find the f of x, right, you get what? 6x minus 2y. That's what they had here, right? It's equal to 0. I told you you're going to change the f of x to 0. Then you find f of y, you get this. Then you solve this simultaneously. When you solve this simultaneously, you're going to get that x is equal to 2 and y is equal to 6. This is the critical point. This is the only critical point. In some cases, you can get more than 5 critical points. 5 critical points is critical points. But if they give you a question and the question gives you in a way that you can get x and y in not a power form, like it's a normal way, x minus 2y is equal to 0 and this one, then you can use simultaneous equation and get the critical point. But in this case, we are not going to use simultaneous equation because they are in power. So this one you will do substitution, right? Let's see how you're going to do it. So with the substitution, it's your choice. You can do this equation 1 and this equation 2. What you are doing here is now we are finding the critical point. So in this case, they said that the equation 1 is 3x squared minus 3y is equal to 0. From here, 3x squared minus 3y is equal to 0. This one change to 0. Then we do some simplification, right? Divide through by 3. You are going to get y is equal to x squared. Then after getting y is equal to x squared, what do? Then you see this equation is equation 1, right? Then we'll substitute this equation into equation 2, which is this equation. So after doing the substitution, we are going to get the values of x only, right? So then after doing the substitution, we are going to get that. We're going to get this. Because we have that wherever we see y, we put in what? X squared, right? And here it was y squared. So we are going to put in x squared minus 3x. And you're going to do, after the expansion, you're going to get this. That means that 3x is equal to 0, which means that x is equal to 0. And x cubed minus 1 is equal to 0. So you're going to get x equal to what? 1. Note, these are not the critical points. The critical points, they are points that have x and y. In this case, we have only x here. So you can also say that 0, 1 is a critical point. So then we're going to do some substitution. After getting the x and the x here, you're going to substitute these values that we've gotten into the equation 1 that we had to get a y value. So in this case, we're going to say that when x is equal to 0, what do you get for y? You get 0. So down the critical point becomes what? 0, 0. And when x is equal to 1, you substitute that into the equation, you're going to get that y is equal to what? 1. So the critical point becomes what? 1, 1. Note this. Sometimes the confusion aspect is here. When you get the x values, you tend it to be the critical point, which will be 0, 1. In this case, that's not it. You are going to use the x value to find the y value. And in the critical points, we have x and y. It's a point which has two coordinate system, x and y. So always you must get x and y. After getting the system, after getting a critical point, then we are going to do what? Classify them whether they are relative maximum, relative minimum, or saddle point. In this case, from the formula from the D, we are going to do this partial derivative of that. We've done it already, so we had what? 6x times 6y minus what? 3x squared is equal to, so when we do that already, we are going to get what? 36xy minus 9. So in this case, we are going to use the critical point to find the value of D. And we've established that when D is greater than that is equal to, when D is greater than that is going to be right. So here, let's take the first critical point, which is 0, 0. When you substitute 0, 0 inside, you're going to get negative 9. In this case, negative 9 is less than 0, right? Therefore, the point becomes saddle point from here, from what we established here, right? If D is less than 0, then the point is what? A saddle point. So we have one saddle point. Then we continue with the second one, which is 1, 1. Let's do some substitution. 1, 1, you're going to get what? When you put 1, 1, you're going to get what? 27. And 27 is greater than 0. But in this case, they made us aware that when it's greater than 0, we have two things greater than 0. So when you get D being greater than 0, that means that we have two things in mind. It can be relative minimum or relative maximum. But how will you know whether it's relative minimum and relative maximum? We go to the partial derivative of the function with respect to x again. So if the f of x ab, which is the critical point, is greater than 0, then it's what? Relative what? Minimum. And if it's less than 0, is what? Relative maximum. So let's see. So then we are going to take what? F of xs, which is what? 6x. Then you're going to put the value inside, right? You're going to put the value of 1, 1 inside, right? So with 1, 1, when we put inside, we know that we have only 6x. So it will be 6 is what? Greater than 0. And if 6 is greater than 0, that means that it's relative what? Minimum. So we've established it here that if it's the f of xs is greater than 0, then it's what? Relative what? Minimum. As simple as that. Let's take this example and also solve that. With this example, they asked us to find all the critical points, and also we should classify the critical points. So first, you need to get your f of x, f of y, then you get f of xx, f of yy, and f of what? Xy. So f of x, partial derivative of the function with respect to x, you're going to get 6xy, then minus 6x, right? That's what you had here. And here to f of y, you're going to get what? 3x squared plus 3y squared, then minus 6y. You had it here. And then we do f of xs. We are going to look for here. We're going to get what? 6y minus what? 6. F of y, we're going to get what? 6y minus what? 6. And f of x, we're going to get what? 6. This, you're going to, with y, you're going to get 6x, right? That's what we had here. Then I told you that for us to find the critical point, what do? We use the f of x and f of y, equate them to 0. So how we've done here, they equate, this is 0, equate it to 0, equate it to 0. This is f of x and f of y, equate them to 0. Then in this case, you're going to do substitution, right? So you can make y the subject here, or substitute and come and put it inside. So here we can know that we can just bring look at it, we can bring 6 out, right? So you get 6x bracket open, y minus 1 is equal to 0, right? And in this case, when you are going to get that y is equal to 1, x is equal to 0. Are you getting it? Yes, x is equal to 0. So in this case, you are just going to do some substitution here. Come and see. And this is not the critical point. Please. In this case, even though we have x and y value, these are not the critical points, because we are going to substitute this value into the equation 2, which is this, to get their corresponding x and y value, which will give us the critical point. So in this case, when you come here, when x is equal to 0, then you're going to put 0 inside this and get our y. So when x is equal to 0, you're going to get that y will be equal to what? 0, and y also will be equal to what? 2. So in this case, we have two critical points here, which will be 0, 0 and 0, 2. And where y is equal to 1, you're going to put 1 inside. You're going to get x values to be 2. So in this case, we have x, y be equal to negative. We have x is equal to this, and also x is equal to that. So we also have how many critical points here? 2. So in this case, at the end, you're going to get 0, 0, 0, 2. And for y is equal to 1, you're going to get negative 1, 1, and what? Negative 1, 1. Please, let me come again. What we had here is not a critical point, because we only use one of the equation. So one of the equations cannot give us a critical point. We need to get a value from here, then substitute the value into the equation, second equation, then get their corresponding values, which will give us the critical point. Be careful of that, because someone come and write this, the critical point to be 0, 1, and that's not correct because you've not done the substitution to the second equation. So in this case, when they had s is equal to 0, they substitute it into the equation 2, and they'll get their corresponding x and y. This case they had y value, so you're just going to do x, y, x, y. So you're going to get 0, 0, and then 0, 2. Here, when y is equal to 1, you're going to get what? Negative 1, 1, and what? 1, 1. And then you classify the points. So with the classification, you already know that you put the values inside. So after doing this one, you had this, right? So you get 6y minus 6 all squared minus 36 x squared. So in this case, when you put 0, 0 inside, right? When you put 0, 0 inside, you're going to get what? The d being what? Greater than 0. And if d is greater than 0, in mind, you can get minimum or maximum. But what you differentiate it is when you use the f of xx. If the f of xx is greater than 0, then what does it mean? It has something. If it's less than 0, it has something. So in this case, the f of xx is what? Less than 0. So if it's less than 0, you go back to it. Let's see. If it's less than 0, then it is what? Maximum. So for 0, 0, f of x is what? Maximum. Let's take note of that. So for 0, 0, here, f of x is what? The point is what? Maximum. Here, the point is what? Minimum. And here, the point is what? Saddle point. Because if the point is less than if it's less than 0, you know that it's a saddle point, and this also the point is saddle point. So at the end, you'll be able to classify the points easily. The whole idea of the relative minimum and the maximum is the critical point. How do you find the critical point? So you can try yourself. Example, it's very simple, as I've explained, right? So you find the values of using one equation. Sometimes you can use the Monton's equation. If you can't use that, you just use substitution. But if you use one equation, you get x and y value. That is not a critical point. You substitute the x value into the second equation to get the y value. You substitute the y value into the second equation, get a what? X value. Then that will be the critical point, right? Thank you very much for watching this video. Kindly subscribe.